Let's see, here we've got some trig functions, so this looks like it's going to be a trig integral. But I'd like to simplify this integrand if we can here and maybe get rid of some stuff. So let's see, integral, we've got 1 plus cosine x over 1 minus cosine x. And let's see if we can change the denominator here by multiplying by the conjugate. So we'll multiply by 1 plus cosine x on the bottom and then also on the top. So I just changed the sign in the middle. And so now let's go ahead and multiply on the top here. So first terms will give a 1. Outer terms cosine x, inner terms cosine x, so plus 2 cosine x. And then last terms cosine squared x. And then denominator, first terms 1. Outer terms cosine x, inner terms negative cosine x, they cancel. Last terms minus cosine squared. And then 1 minus cosine squared is sine squared. So we've got integral 1 plus 2 cosine x plus cosine squared x over sine squared x dx. And I did that so I'd get one quantity on the bottom, and now I can split these apart over the LCD. So this will be integral 1 over sine squared plus 2, and then we'll have cosine over sine squared and then plus cosine squared over sine squared. And then let's see here. We're doing this integral dx. We can integrate piece by piece, so integrate the first function, integrate the second, integrate the third. This will be dx, dx, and dx. And then 1 over sine squared, so let's see, 1 over sine is cosecant. Cosecant is 1 over sine. So we're really doing the integral of cosecant squared x dx plus 2. And then let's see here, I see a function and its derivative. So in this middle integral, let's let u equal sine x and du equals cosine x. So u squared on the bottom, du on the top. So integral of du over u squared, and then plus, and then this last one, cosine over sine is cotangent, so this is cotangent squared, but we don't know a function whose derivative is cotangent squared. Derivative of cotangent is negative cosecant squared, so we know antiderivative of that one. But what we want to do here is trade out this cosine squared for a 1 minus sine squared, so integral 1 minus sine squared x over cosine squared x. I think that's what I want. Oh no, I'm sorry. Denominator is sine squared. This is not cosine squared, sine squared. Dx. So equals, derivative cotangent is cosecant, negative cosecant squared. So let's put a double negative in here. So this will be negative, antiderivative negative cosecant squared is cotangent x, because derivative cotangent is negative cosecant squared, plus 2, and then this is really u to the negative 2 du. Bring the negative u squared up to the top as a negative exponent. So add 1 to the exponent, divide by the new exponent. So u to the negative 1, divide by negative 1. Plus, integral, split these apart over the LCD again. 1 over sine squared minus sine squared over sine squared. And so we'll have negative cotangent x. And then this is the same as negative 1 over u. So this negative 1, let's pull that out in front. And then 1 over u times 2, so negative 2 over u plus, and then this is cosecant squared again. So it's just like what we had up here. And we know that antiderivative is negative cotangent. So we got another, so I'm doing this, integral of each piece. So this one we already know is another negative cotangent x. So I guess we don't need that plus sign. Just end up subtracting. And then here, sine squared cancels with sine squared. This is just 1 over 1. So integral of 1 dx is just x. And then plus a constant. And now we just have to plug back in for our u, which was sine x. So this will be negative. We got a cotan there and another cotan there. So negative 2 cotan x minus 2 over sine x. Minus x and plus c. So that one's a little bit of work. So, but we only used the u substitution plus trig identities and some algebra. And that's sometimes the case with the trig integrals.